In this video we will represent vectors in the plane by a point in coordinate geometry. So if we have a vector somewhere in the plane, we will move it parallel to itself, of course, so that its tail is at the origin. Then the coordinates of its head will define the vector for us. To do that, we need to introduce the idea of a unit vector pointing in the positive x direction. The unit vector is called I. It's a unit vector, so its length or magnitude is 1. The vector 2i is just a scalar multiple of I. So we just double the length of I, but of course it's pointing in the same direction. Similarly, 5i is just 5 times unit vector I, it's pointing in the same direction. Now minus 3i is a negative scalar times I, so this vector is pointing in the direction that's opposite to the direction of I. And its length or magnitude is 3 units. So unit vector I will be a building block for any vector in the plane. That's not enough, of course. We need a unit vector in the y direction, and we take a unit vector in the positive y direction. Actually, we call it j. So 4j is pointing in the same direction, but has 4 times the magnitude of j. Minus 2j points in the opposite direction, and its magnitude is 2. Let's take a look at the vectors 5i and 4j, and in particular let's sum them. Well, we can draw them like this. Well, we could draw them anywhere in the plane, of course, as long as 4j is pointing vertically upwards with a length of 4 and 5i is pointing to the right with a length of 5. So we can show them anywhere. If we want to add them, we could use the parallelogram law. We could just complete a parallelogram here, actually. Well, the parallelogram would actually be a rectangle in this case, and then just drawing the diagonal from this point. The tail of the diagonal would start at this point and end at the other corner. Of course, we could also add them by the triangle law. We could just move this vector 4j so that its tail coincides with the vector 5i. Then we join the tail of 5i to the head of 4j. So that's our vector sum, 5i plus 4j. Now, here is a general picture. We could have a horizontal vector ai, where a is any number. Now in this picture a is some positive number because you can see the vector is pointing to the right, but a could be negative, in which case the vector would be pointing to the left. Similarly, we can have any vertical vector bj, where b is any number. In this case actually b is a positive number because this vector is pointing vertically up. Now if we want to sum these two vectors, we just apply the triangle law. Make sure they're laid out like this. The tail of vector bj coincides with the head of vector ai. So to sum them, we join the tail of the first vector, vector ai, to the head of the second vector bj. Now there is another notation for this. Since we're always working with I and j, we can just disregard them when we want to denote a vector. We can just strip out those the components. Well, they're not components, they're unit vectors. A and b are considered to be the components, actually. So we can just emphasize those by writing them as a column vector. So let's look at these two vectors, p and q. Well, we have to draw a horizontal vector of length 2 pointing to the right because it's plus 2i. Remember, vector I is a unit vector, the positive x direction. Vector j is a unit vector in the positive y direction. So this is I and this is j, so this vector is twice as long as I. It's 2i. And we want to add on 3j. So there's 3j. And we just apply the triangle law. So this vector is vector p. Now more usually what we will do is just plot the point 2, 3. We just go out 2 units and up 3 units. So there's vector p. It's 2i plus 3j. Vector q is 5i plus 1j. So we plot the point 5, 1 and draw in the vector. Now if we want to write p as a column vector, we would write 2, 3. And q as a column vector is 5, 1. Let's get the sum of these two vectors. Well, we could use the parallelogram law. Now let's consider the x component of this vector. So this vector here is p plus q. So I did it by the parallelogram law, but you could use the triangle law. I could have moved vector p up here, add them that way, but it doesn't matter. Okay, so let's get this value here. Well, actually that's the same as summing this value, summing the x component or I component of q with the I component of p. So that's equal to 5 plus 2, which is 7. So the x or I component of p plus q is 7. So as a column vector, 7 appears on top. Now what about the j component? Well, you can guess you do the same. You want to add this onto this here, but that's just adding 3 onto 1, which will give 4. So p plus q as a column vector is 7, 4, or we can write it as 7i plus 4j. Now in general, vector A can be written like this. We use a sub x to denote the x component. So a sub x is some scalar, and similarly ay denotes the y component. For vector B, we call it bxi plus byj, and if we want to add these vectors, well, when we add, we're essentially adding 4 vectors actually. 1, 2, 3, 4, and we can add them in any order we like. So we can add the I components together. Well, they're pointing in the same direction, so we can just add the scalars in front of I. And when we add the j's, we add the scalars in front of j. Well, for subtraction we get a similar rule, but we can think of subtraction as addition also. We can think of a minus b as a plus minus b. So minus b would just be got by sticking a minus sign in front of this. So we do minus bxi minus byj, and we add a onto it. A vector that has its tail at the origin could be called a position vector. So we could call this the position vector for the point P here. The letter R is often used to denote a position vector. So in this case, vector R is AI plus BJ. Let's look at these 3 position vectors. R1 is 3i plus 4j, R2 is minus 2i plus 5j, R3 is minus 3i minus 2j. The modulus of any vector is equal to its length. Well, sometimes I call the length the magnitude. So to find the modulus, magnitude or length of this vector, we just use Pythagoras' theorem. We have a right angle triangle here, so the length of this side is root a squared plus b squared. And as we've seen before, we can use vertical lines to indicate the modulus or magnitude of a vector. So here are some simple examples. These are the magnitudes of the vectors in this diagram. You can just imagine completing right angle triangles and getting the lengths of the 2 short sides of each triangle.